Hi, welcome to Gravitational Fields 5b. The question I ask you is what happens in this part of the graph? Well, first of all, let's make sure we really understand what this part of the graph means. That means our r, which is distance from centre of the planet, is less than big R, which is radius of the planet. And if this number is smaller than this number, well, that means we are inside the planet. It's a journey to the centre of the Earth. So let's think about it. Well, whenever we're trying to join up a graph, always think about what's the point you're getting towards. So now we have to imagine what gravitational force would we feel here at the centre of the Earth. Just have a little think about that. The answer is you'd feel no force at all. You would actually float. The reason for this is that there's an equal amount of matter above you and below you and to your left and to your right, and they're all pulling you in all these different directions. So if you could survive at the centre of the planet, you'd actually be weightless, which is really neat. So we know we've got to get to this point here. The question is, how do we get there? What's the relationship going to be? It turns out it's linear. And the way to think about that is just imagine that every time you go a little bit further into the planet, it's as though you're drilling into a smaller and smaller planet. And that's why we end up with a linear relationship between here and here, up to that, and then a 1 over r squared relationship there. So that's how this part of the graph looks. Gravitational potential is a little bit trickier, because we said 0 is defined at infinity. So when you're infinitely far away, you hit 0. So therefore, you're not going to be at 0 when you're in the centre of the planet. You're still going to have gravitational potential energy. And the reason for that is weird, but bear with me. Some people think you've got 0 gravitational potential energy once you're on the surface of the Earth. Now, in fact, we know that's not true, because you can dig a hole and you can jump in. So therefore you've got to have some potential at the centre of the Earth. You're not actually at your maximal here. You could still lose GP, gain kinetic energy. Yeah? But if you're at the centre of the Earth, you couldn't fall any more. So you might think, well, the centre of the Earth, we're going back up towards our 0 point. But if you're at the centre of the Earth, you could still fall towards the Sun, or fall towards the centre of the galaxy, or fall towards something else. There's plenty of other masses in the Earth. So at the centre of the Earth, you've still actually got some arbitrary amount of gravitational potential energy. There's still somewhere you could fall. So it turns out the graph goes like that. It doesn't get all the way to 0. It gets to whatever point it is that the other masses in the universe are giving you potential energy. So 0 is at infinity, because that's how it's defined, and you just get to some other arbitrary value. The only way to ever get to 0 is to go way out away from everything. So there you go. These are the 2 graphs. A little bit simpler today, be a bit more tomorrow, but I just wanted to go really, really slowly through them to make sure that you had your head around them. There's some questions about the graphs underneath. I'll see you tomorrow.